How are we doing? Are we still breathing? Some pulses out there? Guys, I realized that we are very close to the end of this party, actually, surprisingly close. So depending on how the next question I ask you goes, we have either 5 or 6 classes left. Uh, who here is going home for the entirety of the week of Thanksgiving? Who here is going to be here for the first part when the university is technically open? All right, all right. That's good. That's good news because that means we have at least one more class. I was there's nothing more depressing than showing up here and there's nobody in the auditorium, and so we will do that then. So the first part of Thanksgiving week we will have class, and that means we'll have time to get through one more thing. So we're going to talk about Venus today, Mars next week. We'll also get into Jupiter, Saturn, brown dwarfs on another class. Hopefully, then I think Thanksgiving week, maybe we'll get to talk about life, origins of life, the search for life throughout the rest of the cosmos, which I guess in some sense will tie us back to understanding a little bit more about the formation of our solar system, which we'll wrap down on by way of Uranus and Neptune, which are the sort of missing links, I think, in understanding some emerging paradigms in planetary formation. So that's my plan. We only got 6 classes, including today, I believe, by that count. So we have to stick to the schedule, which means we will only get as deep as we get. And it's entirely up to you guys. I love it when you talk to me. So let's just explore our curiosity with that. I do also have a kind of boring business thing that I did want to talk about, which is your final project. Did you guys get a chance to check it out on Moodle yet? Yeah. All right.
I skipped it.
Check it out. Basically, and I think I've kind of mentioned this before. It's you know, in some sense. All right, so the final project is actually worth a fair amount of your grades, so you shouldn't blow this off. And the reality of the situation is it's not an enormous output at the end of the day on paper. You're going to do, if you work by yourself, it's something like a 10-minute presentation that you're going to upload to your Google Drive and give me a share link to, because I won't be able to watch it otherwise, and I will give you a 0, and that will be terrible. So you're going to upload a presentation. 10-minute presentation, if you work by yourself, is not that big of a deal. But I'm going to really be grading you on how deep the research was that you did to go into that 10-minute presentation. So in some sense, sitting down to record the presentation isn't the big part of it. What I do want you to do, though, is hopefully by this point in the course, you have caught the scent that there are a lot of open questions about our solar system so far. And what I want you to do is to tear into one of them, whether it's a story like we'll talk about today. Why is Venus spinning the wrong direction? That's a great one. What the heck's going on? Or, you know, what else? Well, anyways, it'd be insane if you haven't caught any of these so far. There's a lot of open mysteries, right? I want you to pick one of them. I want you to dig in and find an article about it and learn something. And then I want you to find a different article with a different position on the same matter. I want you to sort of triangulate. I guess it would be only biangulate since you get 2 perspectives. But I want you to have 2 perspectives that you compare and contrast. I want you to really synthesize which one of these arguments makes the most sense to you. And if you do that right, I think you'll just have a better understanding, A, how science works, and hopefully you'll learn how to think a little bit better in the process. So again, the final project is not, the presentation itself is not the most important part. I want you to really think hard and synthesize 2 perspectives on something. And anyways, this is all written up in your Moodle, but I want to make sure that you guys had a chance to ask me questions, and so you can maybe get started on it too. Any thoughts or fears or concerns about this or anything like that? Yeah, Brennan.
I have a small fear that like 2 sources alone won't be enough for an entire 10-minute presentation.
Ooh, I bet it could be. You're welcome to bring in more, though, to be honest. You could bring in 20 if you want to. My point is I want you to really tear into 2 deep. And in all honesty, it would be great if those were technical sources. So I suggest on the Moodle, maybe you start with something like some pop sci website, like Live Science or space.com. And usually when you read those pop sci articles, they're going to say, based on a study that came out in Physical Review Letters B or something. And I want you to go to that study and actually look at it. And I know the language and everything is going to be really hard to parse. But I think that if you spend some time with it, you'll be able to understand a little bit about what the scientists measured, how they interpreted their measurements. I want you to really try. I honestly don't care if you completely fail at it, but I want to see you guys really wrestling with those two perspectives. So I don't care how deep you have to go, but I really want to see you bring two perspectives that you appear to have wrestled with and at least made heads or tails with. And if honestly, if you want help along the way, email me or come talk to me before or after class, and I'll help you make sense of something if it doesn't make sense.
I was just gonna say, two perspectives doesn't necessarily mean only two sources.
No, no, no,
Right?
no.
You could have many sources
Yeah.
that are both arguing for the
Yeah.
perspectives. So just
Yeah.
to clarify that.
Absolutely. Yeah, I think two is the bare minimum to have the sense that there are two ways of looking at X, Y, and Z mystery in the solar system that we've talked about so far. Something like that. Yeah.
Is the actual presentation itself just like our findings on the information and then like our, like how we, like our perspective based on the, like from the two like perspectives that we.
Yeah, it's a pretty so Moodle walks you through what exactly to do. But yeah, essentially, you're going to sort of answer some questions like the who, what, how questions about each one of the sources, and then you're going to synthesize them into, what makes sense to you at the end of the day. That's kind of what it winds down to. And again, like 10 minutes is nothing. I got to stand up here and talk to you guys for an hour and a half twice a week. So trust me, you can talk for 10 minutes about something if you've thought hard about it. You could probably talk a lot longer than that. But I think the reason I didn't make it longer than that was not because I don't think that you should be able to talk longer than that. But I actually think it's a lot harder to talk for 10 minutes about something than it is to talk for half an hour about something if you've read a lot about it. Because you got to actually streamline your thoughts into something approximating conclusions for 10 minutes because it's not very long actually. So the best way to do that might be just to write a little outline and talk your way through it and tell me what you found and start to compare these ideas. Yeah.
Are we allowed to just record audio for this, or do you want us to do video? I know in the syllabus systems.
Yeah, I would if you don't you just like don't have a place to do the video, or what are you afraid of?
Just I was just saying.
Yeah, I think it'd be better for this one to actually see. I don't care if you put your face in it. I don't really care about that, but it might go a long ways if you can, show some figures from the papers that you dig up. Maybe even just show the titles of them. Yeah, I mean, you don't have to do it just to do it. My point is that I think that it would help you. It gives you a nice something to point at while you're talking, and probably more fun for me to watch too. But yeah, if you can do it, if you can blow my mind with an audio only presentation, I guess you can try.
Like a video press could just be a PowerPoint.
Yeah, the best way to do it.
Yeah.
That's what I suggest. So if you read the Moodle, there's way too much information there, but I suggest you read it all. What I suggest doing is basically open a Zoom meeting. You guys all get Zoom for going to school here, basically. And you can just do a PowerPoint presentation and go into presenter mode on Zoom and just present it and record the Zoom meeting. Then you just basically have recorded your presentation. You're talking into it. I record these classes like this on these Zoom meetings all the time. It's pretty straightforward. You just push record. You can record it to the cloud. You can record it to your computer. At the end of the day, though, again, I'm going to say this. I'll probably say this one more time before. I'll say this many more times. You got to share that link with me to your Google Drive, or I will not be able to watch your presentation. Somebody does it every time too. And I also am asking you guys to get these done before the week of finals because I think it'll be a lot less stressful for you ultimately. If you're taking tests and other classes, you don't want to be messing with this while you're dealing with finals. If that's a problem for you, you can come talk to me, but I think that's a smarter way to do it. And in all honesty, it gives us some time to work out any mistakes too that might happen. So yeah, I think that any more thoughts and concerns?
I just want to make sure you're hoping that we would sort of steer clear of the large cosmological.
Let's keep it in the solar system.
Try to keep it within solar system.
Yeah, I mean, those might become relevant, but yeah, stick to the solar system. We are not prepared to look at cosmology. That's next semester, unfortunately, for better or for worse. Yeah.
Yeah, we just touched on a couple.
We touched on some stuff.
Yeah.
Yeah, you're welcome to bring any insight you have for sure. But I wouldn't like pick a cosmological question like
Right.
what's the Hubble tension or something like that. That's kind of outside the bounds of the game for right now. Any other questions? Thoughts? Yeah. Yeah, there's that too. Let's talk about that. So I recommend everybody do just an extra credit project too. What is this? Well, it's basically every single one of you probably has something that you do in the creative. Well, almost all of you do. Actually, when the first week when you guys made videos introducing yourself, I noticed almost everybody had something. Maybe you make music, you paint, you cook. I have no idea. I want you to. I just kind of want to see what you do, and I want you to kind of bring that element to some meditation on what we've done in this class. I don't really. It can be very loosely pegged to it. It can be very, very loosely associated. But yeah, I think that this gives you the opportunity to, maybe you're not a numbers science type person, but you're an amazing poet or something, and you want to write a series of poems about one of the planets that we've talked about that's inspired you, or I don't know whatever you want. I don't really care. It's worth a lot of points, though, in all honesty, and I'll give you points basically based on how much effort I feel like you've put into it. So if you're not happy with your quiz scores, not happy with the workshop, I don't know. Do it. Everybody should do it. It's worth a lot of points for what it is, and you're probably doing something cool and creative anyways that you could somehow tie into this. So, how's that sound? All right. What else? Anything? All right. So where are we in our? Where are we at in this journey, my friends? What happened last week? Remind me. Talk to me.
Doing Mercury, I think.
Mercury, yeah. What was interesting about Mercury? We're getting away from close to home. Yeah.
Mercury have a lot of water.
Mercury has I don't know if a lot of water, but I see what you're saying. Yeah, it does have volatiles, which is quite bizarre considering how close it is to the sun. I think that's what you're getting at. So it has enough water inside and vapor that it's kind of off-gassing in a way that interacts with the solar wind. So yeah, it doesn't have, oceans of water, but maybe under the surface, we don't know. It's pretty bizarre considering how yeah, it's a very strange beast. It kind of looks like the moon, but it really isn't at the same time. Good points. Yeah, what else?
Very large.
The core. Yeah, that was crazy too. Does anybody remember how big the core was, relatively? At least by density? Hold on. Yeah,
57%.
it's something like that. Was it 57? Yeah, that sounds right, actually. But again, this is based on density, right? Nobody's ever actually stuck a measuring stick inside of Mercury before.
I don't think we've done that for Earth either.
No, good points. Yeah. Although we've done at least the seismological echoes and so forth. I think they might have done some radar mapping, radar penetrating radar with Mercury at this point. I'd have to look it up though. But yeah, it's huge. Its core is enormous, especially compared to something like the moon. It's mostly core, which leads a lot of people to think maybe it was a lot bigger at some points. Maybe it got whacked by another planet that's no longer with us. What else? What do you got?
Well, yeah, we brought up because we talked about both the moon and Mars and how not Mars, Mercury, and both have in their formation theories currently some large impact related event.
Yeah, they both are kind of like that, huh? And we're gonna see a little bit more of that today with Venus. Yeah, yeah.
I thought it was pretty interesting with this is only really something I think we covered in the workshops, but the sunrise on Mercury, it would like wobble back and forth sometimes.
Huh. What was that about? I don't know about that actually.
Sunrise.
The double?
Yeah.
Or the sun rises, and then I think it rises and then sets, and then when it rises again, and then kind of goes like in reverse, like
Interesting. Is this because of the 3-2 resonance thing? Like the turning as it rotates? I mean, because it is. Yeah.
Its orbit is so elliptical and then the
Ah,
isn't really positioned in the center. So there's parts of Mercury that the sun will go up and then start going backwards and then
what? Oh my God, I love when you guys tell me stuff I don't know. That's really cool. Wow. Yeah, Mercury is insane. You know, people thought it didn't even rotate for a long time because of the way that whenever they would try to observe it in the morning on Earth, there's this really interesting resonance between the Earth's orbit and Mercury's orbit, where we would always see the same face of it. And it turned out that that just wasn't true. It actually does rotate, but nobody knew it for a really, really long time until they started doing these radar studies on it, when they could actually view it at other times than when it's visible, essentially. Uh, yeah, pretty crazy. What else?
We talk about how it's the closest planet to Earth on average.
It's the closest planet to Earth on average.
Its proximity to the sun is sort of in the center of all of the.
On average. Gosh, averages are funny, aren't they?
Yeah.
Yeah.
We also talked about how hard it is to see visibly with a telescope because you have to basically look at the sun.
Yeah, yeah, and it's hard to get there, right? That's why it's, I think, on the bottom of the list for a lot of exploration programs, because anytime you throw something at the sun, it tends to end up in the sun, which is not good. It's actually not that close to the sun though, which is pretty crazy. No,
Close enough.
it's close enough. It's in the direction. It's the closest one. That is true.
Like
um,
you can't point away from the sun
Right,
to it.
right.
Which,
Yeah, so it's interesting the choices that these huge state science projects have made in terms of which planets they want to go after. And I think we're going to talk about that today because the planet we're going to look at today, Venus, was pretty much ignored by the Western superpowers, and Russia was way into it. We got really into Mars at some point, around the 70s.
Probably because it's the closest planet that isn't in the direction of the sun, I would assume.
Well, that was so the reason that the Russians seem to have preferred Venus is that they thought it was easier to get to, actually, because you do get a little bit of help from the sun.
It's
You
close.
can also, they liked that it had a big atmosphere because that can, maybe I'm getting ahead of myself, but it's kind of like a nice little cushion to catch your spacecraft in some way. Now, of course, as your spacecraft sinks down to the bottom of Venus, you're going to run into other problems, which we'll get to in a second. But before we get to Venus, any other thoughts? There's one other weirdo piece of the puzzle that Mercury's kind of famous for. What else? Any other thoughts? I just want to hit that too.
cratering. It doesn't like it has, especially for being so close to the sun. Like we were just talking about, when you throw things towards the sun, they tend to hit the sun. So how is it so cratered?
Yeah, that's quite interesting too. Yeah, it looks super, super old, kind of like the moon. And then again, this brings us back to the good old heavy bombardment moments, right? Which is this, sort of bedrock piece, hypothesis that all of this cratering must have happened at some very early point in the solar system's formation. So yeah, that's quite interesting. Then there was the last thing I wanted to review was good old perihelion of Mercury too. Does anybody remember talking about this? This got a little bit heavy. Perihelion. Does anybody remember what that meant? What that means? Yeah.
Was that like the moment it's the furthest from the sun?
It's actually the closest. So aphelion is the furthest. But yeah, this is wobbling. So you guys mentioned that Mercury has this really elliptical orbit, right? And it turns out that ellipse is actually precessing around the planet too, very slowly. I pointed out it was extremely slowly, I think, on the order of, what did we decide? Like a centimeter across the sky every century, something like that?
Like 4 centimeters.
4 centimeters.
Like that.
That's right. Yeah, like 500 arc seconds or something. We did the math on it last time. So yeah, so there's two possibilities with that, really, right? That I pointed out. Does anybody remember them? Okay, this is extremely technical, but I think we'll point it out again. So one is that we just have the gravitational math wrong. We don't understand gravity very well, or Newton didn't understand it. Moreover, there's some really tiny corrections due to this Einstein treatment of gravity. It's just a kind of a mathematical argument, essentially, that these little offsets from our standard way of thinking about gravity or wrong, right? That's one possibility. Another possibility, what was the other possibility I pointed out? Anybody?
The core's wobbly, right?
The core, yeah. So, people for the longest time before the Einstein explanation, people thought that there was an extra planet in there, built beneath, interior to Mercury, right?
Vulcan.
Vulcan, exactly. So if Vulcan was there, Vulcan might drag Mercury around, might drag its precession around, right? The reason that this was such a mystery was that everybody's orbits are kind of precessing, but we can account for all the other planets' precessions because, well, we know of the other planets, and the other planets around them account for it. Mercury seemed like it had a partner, but we never found it. We never found planet Vulcan. And so, this other kind of wild possibility is that perhaps the actual core of the sun is in a different phase state than the rest of the sun, and perhaps it actually is lopsided in some sense. And so, in some sense, the planet Vulcan hypothesis might be resurrected in the form of a sort of lumpy core situation. The lumpy core is also intriguing too, and this is beyond the bounds of this class, but we'll get into it next semester. The sun changes its magnetic field polarity every 10 years or so, which is crazy. I mean, ours takes almost 1,000,000 years to do that, right? And we talked about how that might happen if the core did this kind of tumbly thing, right? And we've seen this in outer space. I showed you guys. Remember the picture I showed you, or the video of the little wing nut flipping upside down and stuff like that?
Yeah.
So maybe something like that's going on with the sun too, right? So I don't know. I think there's a really cool science emerging around that, and there's only a few papers about this out there, but it's an interesting idea. And in some sense, yeah, in some sense they don't have to be mutually exclusive too, I think. But yeah, so much in the way of Einstein's, let's see, the preeminence of this general relativity theory had to do with the behaviors of objects around the sun, which is quite interesting. The success was measured based on the motion of certain things around the sun, and so the sun's kind of at the heart of all of this. But we'll see. Time will tell which turns out to be the case. Obviously, but yeah, math mistake is the popular idea right now. All right, we done with Mercury? Yeah. Should we talk about Venus a little bit? All right.
Or hot sister world.
Venus, yes, it's hot. It's very hot. Venus is actually, I think I might have previewed this last time, but it's kind of counterintuitively the hottest place in the solar system, which is pretty weird because it's, several 100,000 more kilometers away than, it's very, very far away from Mercury. I'm not going to, let me not put a number on that because I don't know it off the top of my head. It's quite a bit of ways, but it's still hotter. So why in the world is that? Yeah.
The greenhouse gases in the atmosphere keep the heat trapped to the surface.
Yeah, it's pretty bizarre. It's got a really, really thick atmosphere. So, the greenhouse story is part of it. The greenhouse, of course, the greenhouse narrative, which has gripped, let's say, the environmentalist movements on Earth since the 80s, actually rose alongside the Venus story about the greenhouse narrative with Venus's plight as well. Now, having a really thick atmosphere on its own, greenhouse insulation aside, having a really thick atmosphere is actually very nice for keeping heat in place, right? Yeah.
Isn't Venus also quite volcanically active?
It's weird. Yeah, we'll get into that. It appears that it has been, and it may be again, and perhaps it must have been, in so much as its air, this thick atmosphere, seems to be a really, well, let's say people mainly believe that it must have been super volcanically active because its atmosphere is believed to be a product of the outgassing from these volcanoes. But we don't really see active ones at this point yet. It's still a bit contentious whether the volcanism is sort of a periodic phenomenon that crops up from time to time. There are volcanoes that people point out. I'll show you a picture of them. They're pretty weird. They kind of look like, you guys ever like go out in the woods and see like when an elk poops, it's kind of like a smashed little patty thingy? You guys ever see this before?
They're not like the explosive ones on Earth. They're not
Yeah.
stratovolcanoes.
Yeah.
Like Mount Shasta.
Yeah, they're kind of like these
The weird
pools.
Field ones that just ooze.
They're very strange, yeah. So we'll come back around to that. But yeah, there appears to have been something that happened with Venus, and we'll get around. Let's get around to its atmosphere in a minute. 'Cause I've got some pictures, and I want to talk about those volcanoes. I want to talk about the convection. Maybe we can get a sense a little bit closer to a story of what's been going on with Venus. I'm afraid that the certainty with which we can say anything for sure about its natural history is worse than Earth, and Earth is pretty bad, and it's worse than the Moon, and the Moon's pretty bad. So it's hard to say with any certainty, but we have some different theories we can compare, which will be fun. There's another piece of Venus, which I hopefully we'll have time to touch on a bit too, which is that Venus has probably been the most important planet to everybody since ever, basically. All of the ancient cultures were I think I can safely say that almost all ancient cultures had some story that was central to their mythologies that revolved around Venus. Yeah.
Is it? I would assume it's probably because it's really, really bright in the sky.
Yeah, that's part of it, I think. Yeah, that's a huge part of it. I bet you that's 50% of it at least. So, you guys seen Venus? Everybody seen Venus? You guys probably don't wake up early enough. Yeah, so you can see it at night sometimes too. And I think that that's also essential to it too. So Venus is, I'm going to get a little bit out of order, but that's okay. I'll come back to these pictures in a second. So this is just a comparison of the apparent magnitude. If you guys think way back to like the first or second week of class, magnitude has to do with how bright stuff is in the sky. It has a really insane system of numbers associated with it because it was set up by really early astronomers before they had modern telescopes. And so they wanted the numbers that were the brightest to be the smallest. They ran out of space at the small end and started making negative numbers at some point. So at any rate, the apparent magnitude of Venus on average is minus 4.14, which is, basically half as bright as the sun there. Now this is like a non-linear scale though, so it's smaller. Did I say the sun? I meant the moon. It's smaller. Here's actually a picture of it. If you guys want to see the Venus right next to the moon, it's pretty little, but it's quite bright sometimes. And of course, depending on where the Earth is in its trip with respect to Venus, we can be really close to Venus because it's interior to us, or Venus can be really far away. So it has a pretty large variation in that. Now, can you guys see in this picture that Venus has a little crescent on it?
Yeah, it looks like a line instead of an orb.
I want you guys to see if you can see that when you go and look at Venus. There's people who were reporting that it did have a crescent before the advent of telescopes, and there's people even today, if you like go on Reddit or something, who are like, I can see the crescent. I can't see the crescent, but my eyes aren't great. I'd be very interested if any of you can see the crescent. You can see the crescent? You can? Are you kidding me?
I probably
This is my lovely wife in back, by the way, Dr. Anastasia Benderberry, and my wonderful parents who have also decided to join us. Sorry to call you guys out.
I probably could have just because I'm farsighted.
Yeah, I don't know. It's a really interesting thing. There's been a few reports throughout history. At any rate, if everybody could have seen that, it probably would have solved the geocentric versus heliocentric debate, right? Because why does Venus even have a crescent, right? It's because it's interior to us and it's revolving. Just like the moon's revolving around us, we see these phases. You can see the phases of Venus as well. Let's go back and look at this. So, as Venus is making its way around the sun, just like with the moon, you get the same phases. You get the crescent phases, you get the waxing, the waning. It's the same situation, right? And of course, eventually Galileo pointed his telescope up there and he saw that, yeah, it definitely has a crescent sometimes. It's definitely doing this phasing thing. It's definitely going around the sun. Bad news bears for the Ptolemaic astronomers, but they adapted. and everything went on just fine. This is another fun thing too. Every once in a while, and I do mean really once in a long while, Venus will actually pass in front of the sun, which is really cool. Now, I regret to inform you that you will never see this, unless there's some insane advances in modern medicine, which allow us to live until the year 2117. Maybe you guys will live to 2117. See, how old would you guys be? It's possible. Maybe you guys will see it. This happens very, very infrequently. And the reason that it happens so infrequently is because Venus is actually its orbit's tilted in such a way that it's quite rare that it'll actually be perfectly aligned with the sun in such a way that when it passes in front of it, it's actually obscuring the planet in such a way that we can actually see the thing. So let me see, when was the last one? I believe, and it usually happens in pairs, by the way. So the last one was in 2004 and 2012. So if you missed, did anybody see it in 2012? No, I didn't either.
I know my parents did.
Your parents saw it. That's really cool. Did they take pictures? Awesome. Yeah. I didn't have, let's see, where was I in 2012? I was trying to get into grad school, I guess. I was busy. I was not paying attention to the Venus. This is also kind of cool. So the pattern that it traces out with respect to the Earth is actually quite beautiful. This is if you put the Earth at the center, right? This is again part of the reason why I think that those Ptolemaic astronomers were completely convinced that the Earth had to be at the center of the solar system, because it's a truly beautiful pattern that's carved out if you place us as the reference point with respect to Venus's orbit, right? I mean, weird ellipsoid thingies or beautiful flower pattern, which one does God prefer, right?
Wow, it's almost like they made the same thing.
Yep. So that's kind of interesting. Of course, that is not the way we look at it today. All right, so let's talk about Venus. It's a pretty strange one. I think it's maybe in terms of its orbit and rotational dynamics, it might be one of my favorite mysterious planets. I think it might be one of my favorites. I'm kind of partial to the Neptunes and Uranuses too, for reasons that we'll explore soon enough. But there's something kind of amazing about this guy. So its day, if we map its day by how long it takes to turn around with respect to the background stars, 243 Earth days. And it's going backwards compared to every other planet in the solar system, which should be super exciting because it means something crazy has happened in the past. And we have a huge theoretical space to explore what that is. So I'll talk about it in just a second. What's even weirder about the fact that its day is 243 Earth days is that its year is 225 Earth days. So its year is shorter than its day. That's pretty far out. So this is, by the way, a infrared image of the thing. In reality, it's like we just mentioned briefly at the beginning, it has a really, really thick atmosphere, so you can't actually see its surface. You just see this, which probably is why it glows so beautifully in some sense, because it's very diffuse. You could imagine it's kind of like one of those old gas lamps in a way, I guess. Yeah.
You know if we managed to get any probes on the surface of Venus?
Yes, we have, for sure. Well, we being our friendly Soviet neighbors actually did all of the work on that. I'll show you some pictures of it in a second. Before we get there, though, again, this is the story. This is the diversity of not orbits, of rotations that we have in our solar system, right? And again, Venus is pretty cool. It seems like, in some sense, the most bizarre and weird one, since it's orbiting the opposite direction. But some of these other guys are orbiting in strange inclinations as well. It's almost like Earth and Mars are paired really nicely. Their tilts are very, very similar. Saturn's pretty similar to that. Jupiter is pretty well righted, and Mercury, of course, is almost exactly the same as the Sun, which is also quite interesting. You know, there's always this argument which comes up when we think about moons and we think about whether this moon could have been captured by this planet or the other planet. And oftentimes the argument that you encounter for why a moon couldn't have been captured is that it's very difficult to stabilize a rotational system. So it's very difficult to have something get captured, and it would take a really long time for it to right itself and enter into the proper rotational dynamics, and then eventually become tidally locked. So it's kind of rotating synchronously with the planet that the moon is orbiting. We talked about this a little bit before with our moon. But that's kind of a weird argument because there's all sorts of diversity in terms of the way that the planets are rotating, right? And so I guess in some sense they actually seem quite like they've entered into their current positions at very different time periods using the same logic, right? It's quite tantalizing to imagine, you know, how each one of these could have had a very different story for how it ended up where it ended up based on just their gyroscopic precession alone, just how they're turning exactly. Yeah.
This might sound like a dumb question, it just popped in my head, but we the angle of all the planets, the tilt,
Yeah.
what is it relative to?
The sun
Okay,
or the ecliptic, right?
that's what I assumed.
Yeah, so all the planets kind of orbit the sun's equator in some sense. That's one way to think about it. And we call that plane the ecliptic. So
Gotcha.
it's with respect to that. Now, you know, the very last class we do here, we will survey formation models, how all of these planets ended up where they ended up. I wish we had a whole semester for that because it's really fascinating, all the possibilities. But you know, some of the standard model does have certain ones of these planets moving positions in their orbits, particularly the Jovians, you know, Saturn, Jupiter. Some of these things are moving around a little bit, but in general, like the story is still a little bit half-baked in terms of why some of these guys are tilted on their sides and why some of them aren't. I mean, look at Uranus. That's a pretty bizarre one too. But let's get back to Venus because the theories for why it's flipped upside down are also quite diverse and interesting. All right. So we talked briefly about the story for Venus and how it's been really important to people since pretty much ever. Now, one reason for that is that it's the brightest. They used, you know, for the ancient peoples, it was the brightest star in the sky. But it does something else, which is really, really strange. Does anybody know what I'm getting at here? So most ancient peoples actually thought of Venus not as, first of all, they definitely didn't think of it as a planet. They had, till the Greeks really, even the Greeks thought planets were just these weird stars that danced around. They thought this thing was two different stars, actually. They thought it was one star when it was in the evening and one star when it was in the morning, right? Now, why does it appear in the evening and the morning? This is kind of similar to Mercury.
Because it's near the sun.
It's interior, right? It's near the sun. It follows the sun around, essentially, right? So when the sun is setting, it's still interior to us. We see it kind of chasing the sun down over the horizon. Now, why would it come up on the other side?
Because it's coming up with the sun.
Yeah, it's going around on the other side of the sun, right? So it's going to kind of lead the sun up as it comes for part of the year. Now, all of our ancestors had no idea in terms of these orbital mechanics, right? This wasn't the way they were looking at the world. But they did notice that there was a star that chased the sun down at night, and they noticed that there was one that preceded it and rose before the sun for the other part of the year. So I think it's somewhere on the order, let me look this up so I don't screw it up. It's a morning star for about 263 days. Then it disappears behind the sun for 50 days. Then it's an evening star for 263 days. And then it's in front of the sun for 8 days. And you can't see it. It's actually kind of below or above the sun because of the angle of the inclination with respect to us. So that's really interesting. And I'm going to try to reserve maybe 10 or 15 minutes at the end to review some of the stories that people told about it. But this is this is in some sense a core piece of almost every single mythology stems from this Venus story, and I think that it's gonna prove to be quite profound. So while we're still talking about Venus as a rock, we can keep in mind that it does this really strange dance just due to its position that, Mercury does to some extent, but Mercury, again, you'll be lucky if you ever see Mercury. I can't see Mercury ever because I live in a basin, basically, and it's really only above the horizon for a few minutes at sunset for me. But everybody could see Venus. Like if you wake up early or look in the sky at night, depending on where it's at, you will be able to see Venus for sure. Super bright. And I think that this pattern of appearing and leading the sun and following the sun, it reflects something deeply human that everybody seems to have latched onto. And surprisingly, people all around the world from completely unrelated cultures tell really similar stories about their gods that reflect this Venus transition. And we'll work our way to that. So keep that in the back of your head for a second. Let's talk about the thing as a rock, though, for a second. So Ezra is asking if we'd ever put a rock down there. Yes, is the answer. This is actually some of the first pictures that came back from the surface of it. So while the U.S. was, well, what were we doing back in 1962? Vietnam comes to mind. What else? We were working on a lot of ballistic missiles at the time, some of which went into the Apollo program. The Soviets,
Stuck a human on top of him, said go.
yeah, some of that started to happen, but actually the U.S. sent a flyby at some point to go and check out Venus and get some pictures called Mariner 2. But 1970 was the first time that the human beings had actually ever landed anything on another planet, and it was Venus. So it was actually the first planet that we visited, and that was part of the Russian Venera program, which is quite interesting. And like I said, I think that the Russians preferred it because it was nearby. It was closer than Mars. It was easier to land on because it had this big, soft, squishy atmosphere that could kind of catch their spacecraft. And they did this many times. They had many of these Venera probes. Now, the first one that hit the surface, I think it was 7. Yep. How long do you guys think it lasted on the surface?
Couple seconds.
More than a couple. It lasted for actually 23 minutes.
Oh, okay.
Not bad. Now, what happened though? Why did it only last 23 minutes?
Did it burn?
Yeah, it's what? Anybody? Any ideas?
Just like,
It's hot. It is hot. It's about as hot as a pizza oven. What else? Hot enough to melt lead and some other metals for sure. What else? Yeah,
it crushed my dust.
it's that atmosphere is so heavy. Actually, it's about like going scuba diving a kilometer under the ocean. That's about the weight that would be sitting on your head as a spacecraft, right? Now, in and of itself, should be able to send a probe kilometer beneath the ocean, right? And I think that with proper equalization, this is possible. And modern submersibles can do this. But the combination of the heat, the pressure, and one other element, what is it? As if things weren't already hellish enough.
Radiation as it approached the
Actually, the radiation's quite nice. That atmosphere shades.
under the atmosphere. I mean,
Mm.
to the sun.
I'm thinking of one more thing. Yeah?
Did they lose contact with it?
No. It's got basically battery acid for an atmosphere. So think about it. Battery acid atmosphere, hot as a pizza oven, and the pressure like you're, kilometer under the ocean. It's not a good situation for spacecraft. And actually, it's kind of amazing that they even lasted as long as they did. The record, I believe, is 127 minutes. So, like a full-length movie worth. Now, the Russians are the only people who have done this so far. There are some plans to go back. There's a program called Da Vinci. I actually had the pleasure several years ago sitting down with the lead scientist from the Da Vinci program at NASA and talking to him about this plan. And they also don't expect that their probe is going to be able to last very long on the surface. So what do you think that what clever solution do they have in order to study it as long as possible? Yeah,
Send as many probes as possible.
that's a good one. I like that. That sounds expensive though.
Load it in the atmosphere.
Yeah. That's basically it. Yeah, they're basically going to try to descend the thing with some fancy version of a balloon parachute type thing and have it study Venus the whole way down so that by the time it gets to the worst conditions possible, they've got a ton of data sent back already at that point. Now, the thick atmosphere of Venus is actually pretty cool though too. I've seen the line between, science fiction's often actually gives real space exploration ideas sometimes. And there have been some reasonable arguments that you could set up a pretty stable space station on Venus. How would you do that?
That would float on the atmosphere.
Yeah. There's a point actually in the Venetian atmosphere where, if you go up high enough, you basically get to a point where the atmosphere is the same pressure as it is on Earth, right? And so you could basically have a little space station up there that's kind of, traveling around, orbiting Venus, studying it, doing whatever it does. It's not that far away. It'd be pretty easy to actually resupply, refuel. Actually kind of promising possibility. Some people think that for the same reason, it's possible there might even be, despite this hellish conditions at the surface, there might be some weird little critters living in the atmosphere at these elevations as well. I heard a really interesting theory recently that there could even be a life cycle where, have you guys, so let me think how to introduce this. You guys ever heard of bacterial spores before? Pretty crazy little things, right? So bacteria sometimes make these little, certain bacteria, especially really primitive ones, they sometimes, when they're starved, they will make these really tenacious, protected versions of themselves. It's kind of like a little seed, if you want to think of it that way. But it's super protective. It can stand radiation, incredible temperatures. It's actually the reason that food safety is so difficult to guarantee in some sense, because it's really hard to kill spores. They're so resistant to all the things that we would try to kill. Pressure, temperature, they can withstand basically, it would not be unreasonable that a spore could withstand the surface of Venus, I suppose. And so there might be a life cycle where the bacteria, sporulates, and there are actually these dormant bacteria on the surface, and they get kicked up by these insane winds that happen, right? Because it's a really thick atmosphere, so you get these really powerful wind currents as they go over some of these features on the surface that we'll look at. And you could have literal bacteria living in the atmosphere. Now, it sounds kind of crazy, but do you guys think that we have bacteria living in our atmosphere?
Probably.
Sure do. Really high up too. Really high, miles up in the atmosphere. Yeah. What would they eat? That is a great question. So bacteria are insane. They don't eat cheeseburgers and stuff like the rest of us. Sometimes what does it take to basically eat, to be alive, right? You know, And honestly, I hope that we can get more into this, because we're going to talk about the origins of life and what it means to be alive and all of that. Hopefully, I think we'll do that the Thanksgiving week. But they basically need they need some sort of carbon source to disassemble, right? That's you can think about that as like your bread or whatever the heck you're eating, right? And they need some sort of something to respire, right? Something to basically they're taking energy from one thing, they're funneling it through their bodies, their little bacteria bodies, and then they're kind of there's like essentially a waste where they're basically depositing that, they're kind of inserting themselves into an electric circuit. Now, bacteria have shown that they're able to do this with this respiring process with rocks alone, basically, right? They can respire on metals. And so as long as there's some sort of carbon source that they're able to take apart, it seems like they might be able to do that. Now, there have been, I don't even think it has to be carbon sources. Nasty, are you with me back there?
Yes.
Do bacteria have to have carbon sources, or can they have like phosphate sources as well?
Bacteria, but they can have nitrogen phosphates.
What do they call? What is this called? They need some sort of, what do they call it? An electron donor of some sort.
They need an electron donor in order to, so basically.
They're kind of like battery. Like life is kind of like batteries. Like you have a terminal where the electricity's got to basically flow from one end to the other. For us, it's food to air, basically, right? But with the bacteria, it can be something else. And we'll talk more about this later. But there's a lot of possibilities how that could play out. And every once in a while, somebody finds some signature in the atmosphere of Venus where they're like, that looks like it might do the trick. That looks like that's something that we usually associate with life. And then the whole scientific community, gets really upset. And this has happened a few times. Yeah.
I mean, it wouldn't. Most life on Earth is carbon based, so it wouldn't surprise me that there's some. I mean, most of Venus's atmosphere is carbon dioxide, is it not?
Yeah. There you go.
A lot of carbon.
There is a lot of carbon. Yeah. I mean, it's one of those things that it's understudied. Is the truth of the matter. It's fun to play with the fact that there might be other ways that life sustains itself than the ones that we're familiar with too. And so, we haven't found it yet. Maybe we will. It's a possibility. So what else can we say about this? This is another picture from the surface. It's kind of wild looking, actually. One of the most interesting and perhaps bizarre features of Venus is how young the surface looks, actually. Look at this. I mean, there's really very few craters on the surface of this thing, right? And maybe, so that's one thing I want you to keep in mind. It's going the wrong direction. Its surface looks really young. Let's throw in something else that's kind of weird. Basically, it has a similar composition and density to our planet, but it has no magnetic field. That's pretty bizarre too, and we've talked a lot about magnetic fields already. So those are all kind of strange pieces that we need to fit into our story about Venus as a whole. Whoa. All right. So the US got involved later in the 70s. We started making these radar maps of the thing to try to get a grip on the surface. This was the Magellan program. These are really this is sort of a altitude terrain feature. Let's look at the terrain. So these are the volcanoes that Dante was talking about. This is a pretty weird looking kind of volcano, right? Now, if I can recall correctly, when I was talking to Garvin, the Da Vinci scientist, they were really unsure whether the volcanoes were actually still active in a sense or not. It wasn't immediately obvious that they were. And so in some sense, the standard narrative about Venus points backwards to a time where the entire planet was resurfaced really violently. What do they call this thing? They have like a name for it. It had like, I think they call it like the Great Resurfacing Event. But essentially, if you actually do the kind of calculation that we did with the moon, remember when I told you guys, if you actually looked at the rate the moon was getting hit by asteroids, it would be really old, right? Like older than the universe is supposed to be. And this is the case with other bodies in the solar system, hence the creation of this heavy bombardment period early in the solar system when all these craters happen. If you do the same project with Venus's surface, you do find impact craters. It's not that it doesn't have any. It's just that if you trace them back at the rate at which it's getting hit with stuff these days, the surface should only be maybe 300, maybe 800, something in there, let's say 500 million years old. Not that old, right? It's a pretty fresh looking surface. So something really weird happened quite recently. Now, did that weird thing happen? And so what resurfaced it? Well, one possibility is what resurfaced it was some massive volcanic event, right? Where these, basically the Venus cracked open and started leaking magma all over the place. If you go back and look at the surface, I don't know how well you guys can see this picture, but it kind of looks like, have you guys ever like been to a volcano field like St. Helens or something like that before? It's very magmatic looking on the surface here, yeah.
Yeah, it reminds me of I forgot where it was in it was in eastern in coastal Oregon, but there's some Shilo volcanoes there. Some
Mm,
volcanoes
very extinct ones.
very I mean Hawaii is similar to some
Mm-hmm,
volcanoes,
mm-hmm,
so they're very the viscosity is very low for the lava
mm-hmm.
and it looks kind of like that. It
Yeah.
looks like the ocean floor in the deep ocean kind of looks like that.
Yeah, yeah.
Just
It really just
bare,
looks
like
like it looks like an old cooled, to me, and I think to other people too, it looks like cooled magma fields in a way.
if you've ever been to Table Rock,
Yeah, yeah.
it's the remnants of a
That's the story too, right, right,
on-
right. Yeah, it's kind of similar. It's kind of a similar story with Table Rock, that's right. Yeah, so it's kind of strange. So the idea that well there is evidence for these weird volcanoes. I just threw up a picture of one of them. There's some of these kind of like patty-like volcanoes. Let me see if I can pick. I had a couple more pictures of these things. Here's some other pictures of them. Kind of strange looking, like sort of just puddles volcanoes. But again, there's craters on top of these for the most part. It seems like it happened a while ago. I don't know, in so much as couple hundred million years is a while ago. Yeah,
I just looked it up. They said it's like probably 300 to 500 million years. Their theory.
nice. Yeah. So, depending on how you chop up time, that's pretty recently. If the standard story is that all these planets started, let's say 4,000 million years ago, which is 4 billion years ago, or something like that, 4.5 maybe. 500 million isn't. It's fairly recently in the whole timeline. Maybe they're much much older than that, but even that only makes this even more recent. So something weird seems to have happened, and the sort of the stories for what could have caused that are nobody really knows. There's a lot of argumentation in the literature about this. And people try to tie it together with the story of what happened to the magnetic field. Why is the planet inverted? A lot of people imagine that there's basically two ways of imagining this. Maybe every once in a while, maybe this has happened many times on Venus. Maybe because unlike Earth, it doesn't have regular venting of its surface, right? It doesn't have these nice plates that are fractured in such a way that it can actually have convection really nicely. So you guys remember convection, you have to have the flow of something warm to something cool, right? To get these nice cells, this is the mechanism by which you really get all that roiling underneath the surface that gives us the ability to have the motion necessary for that magnetic field that we talked about, right? So maybe one series of possibilities is this kind of stale lid theory for Venus. It's got this really hard crust. It's got maybe some heat internally, but it's not really able to convect properly in any way, in any appreciable way, because the lid's solid and it can't really move. But then every once in a while, something, who knows what, some black swan events. Maybe the planet tilts, maybe it gets whacked by a passing object. Maybe it only happened once in its early history, it got hit by something really big, which knocked it upside down. Nobody knows, but whatever it was, perhaps that event was the same event that happened 500, whatever we decided, 500 million years ago, which led to the crust cracking in such a way that all this volcanism happened. Yeah.
We talked a little bit about decompression theory, I think, earlier, right? And I don't know at what point there's enough evidence to just, if the pressure of Venus's atmosphere is keeping that contained, and intermittently it's losing atmosphere as it, solar events and all that stuff. That seems to line up with the story that the decompression theory. And I don't know.
Yeah, well, they actually think that this is one of the few planets where the standard narrative, so this is another common feature on Venus's surface, these little stretch mark thingies. So they actually do think that the thing has been stretching and decompressing. So that's interesting too, right? Again, in terms of putting a cohesive story on this thing, you really, in some sense, have to open your imagination to like different timescales in which you want to tell the story on, right? Did Venus look completely different, let's say 1,000 million years ago? Maybe. Did it look completely different and then something insane happened? I don't know what. Maybe it got whacked by another planet that crossed its orbit, which is now inside of the sun and we'll never know about it, which turned it upside down, unleashed its volcanoes, completely remodeled its atmosphere. Or maybe there was a ridiculously huge solar flare that completely cooked off its atmosphere, changed its atmospheric chemistry. Maybe it destroyed the oceans that used to be there. That's another really interesting theory about Venus. So a lot of people think Venus used to have huge oceans. Why do they think that? Anybody? Why would you ever say that? Yeah.
Probably because the surface kind of looks like the um, surface of our like the bottom surface of our deep oceans.
Yeah, it does have these kind of like oceany looking basins and stuff. That's part of it, I think. Um, this is kind of related to the story that we told about why people think they know the temperature of the Earth during the glaciations and all of that.
Oh, because all the oxygen.
Yeah, different isotopes, right? Different heavy isotopes. They're actually looking at hydrogen isotopes. So what they see is that there's actually more heavy hydrogen than regular hydrogen. And, and so the idea is that basically the oceans boiled off, so they ended up in the atmosphere, which contributed to this runaway greenhouse effect, which helped heat the planet up. And there's this basically this entire story that terminates in oceans getting boiled off. Now, I would say that it's a pretty it's both a reasonable story, but also far from certain or conclusive, right? It's somewhat unsubstantiated at the same time. There's many different ways actually that you could end up with that heavy hydrogen in the atmosphere. People don't really even know if the magmatic surface that we were just looking at contains water. Like we actually have a sense that it does on Mercury. We don't know about Venus yet. So one possibility, an alternative to this, is perhaps the oceans got gobbled up by the magma, maybe during that resurfacing event, that in some sense you dissolved a lot of that water into the ocean. We don't know, actually. But the popular story that emerged does involve the oceans cooking off. But I think that there might be a more humanities bound explanation for why people think that. Well, we can play with that in a second. Let me see, make sure I didn't want to hit anything else. Yeah, I mean, so a lot of this narrative, this story about Venus having this runaway greenhouse effect, the oceans boiling off, this story was really developed in the 1980s and into the 1990s as the world became kind of obsessed with the same possibility for our own species. So this is kind of interesting, actually, the unfolding of the stories that we tell about Venus in general. And you know, I think that this is quite interesting in the context of the fact that people have been obsessed with telling stories about Venus for so long. The most recent story we tell about Venus kind of, I think, reflects our deepest fears about what might happen to our planet as well. And if I recall, I haven't actually read your chapter on Venus in your textbook in a while, but last time I read it, I believe that it was definitely centered on the idea that if we're not careful with Earth, the runaway climate change on Earth would lead to a situation kind of like Venus, yeah?
Yeah, I hear most of the time when I've ever heard people talk about Venus, it's almost always in reference to how Earth would become like Venus.
Yeah,
There's is like the exact opposite of Earth. I've often heard Venus described as hell and Earth as paradise.
yeah. Yeah, so I think that there is a story that you can tell where Venus used to look a lot like Earth, and because this equilibrium got tilted out of balance, you know, the oceans were evaporated by some sort of solar intensity at some point, or you know, chemical processes that led to this. Perhaps the spin was not correct. I mean, there's lots of reasons that you can imagine to make this happen, but it basically creates this feedback loop, because once the oceans are evaporated into the air, well, when we were talking about the Earth and greenhouse gases, what's one of the best greenhouse gases?
Oxygen.
Methane.
Put them together.
Water.
Water, yeah, water. So, you basically then make this blanket. Of course, then the water is eventually getting dissociated by all of this intense radiation from the sun. The hydrogens break off. They're really light. They can't hold on. Gravity can't hold them. They fly away. There's definitely a story that can be told. But I think in some sense, every time, I listened, actually just for fun this week, listened to a few different like popular astronomy podcasts about Venus. And they all told, all three of them centered on this sort of narrative about how the Earth was like, we had to be careful with the Earth because we didn't want it to turn into Venus, kind of thing, which I actually think is like a really good point. We should be careful with the Earth. It would be terrible if it turned into Venus. But I'm not sure that that's necessarily what happened. But I do think that it reflects quite a bit about the way that we're thinking about our current situation. So kind of what I wanted to do for the last 10 minutes or so is think about the way that people have looked at Venus before they had telescopes, because I think that they did the same thing back then, even when they didn't have telescopes. They told stories that reflected the way that they saw their own lives. One of the earliest people that we have a record of, and at least in the Western tradition, is the Sumerians. We talked a little bit about the Sumerians. Does anybody know who the Sumerians were? The Babylonians, let's say, are their kind of cultural inheritors. Yeah,
Mesopotamian.
Mesopotamians. So where is that? Does anybody know in modern world? I know you know. Hold on. Yeah. What's that? Middle East. Yeah. Where specifically?
It's like, is that Egypt?
Nope. Not even close.
Well, I'll give them close. Yeah, it's in Baghdad, basically. It's pretty crazy. It's actually in Iraq, right? It's the cradle of civilization.
In Iraq.
No, Iran's off. Yeah, you're right. Iran's kind of off to the side, over here, and then this is quite interesting. So the cradle of civilization is kind of, it's weird too to imagine this, because when you think about Iraq and Iran, you think about these like kind of desert, like very Martian places almost in a way, right? Which is kind of weird. So why in the world did civilization start in these Martian hellscapes? Yeah,
Because they weren't Martian
They-
hellscapes back then.
that's right. Yeah,
They were. They had more water, more lush
yeah, they were really, really nice, actually.
They changed because Mesopotamia literally just means the land between the two rivers.
Right, right. So this is a kind of a weird feature too about climate change that I just want to impress upon you guys. The climate is always changing. It always destroys civilizations when it changes, because nobody knows what to do when it changes. And maybe destroys in the right word, because usually people just move over. They like go somewhere else. The seat of civilization ends up, over here. It leaves Greece and goes to Rome. It leaves it leaves Mesopotamia and goes to the Levant on the interior by the Mediterranean, right? So in some sense, people have there's this cyclic pushing around by climate all the time. Certainly it wasn't because of their automobiles back then, but it was very, very difficult on the people. And so I think even the story we tell now about Venus being this climactic apocalypse is something that's really deep in our souls as human beings. It's something we've been really worried about since almost the beginning of history. I'd say before history. People have been aware that things change, and it's really scary. So anyways, the Sumerians associated the planet with this goddess named Inanna, and later the Akkadians and Babylonians, who were, let's say, took over the place a little bit later, they called her Ishtar. And what's kind of interesting is that because there's two stars, they associated it with this goddess with two different elements, one which is love and one which is war, which is quite interesting, that you would put love and war, sort of in the hands of the same. They were a pantheistic society, so they had lots of different gods, but they put these two together.
Was fair in love and war.
All's fair in love and war. That's right, Dante. Which means to say that it is not fair at all. And So they basically told this story. Remember how I told you guys Venus does this really weird thing. It's in the evening for a while, most of the year. Then it disappears for a while, a little bit, and then it appears in the morning, right? So the story that we get from, um, from these early traditions, and we're going to see that it persists all the way down, basically, to very close to the present, is they tell a story of this deity who basically gets in some sort of a heroic struggle, ends up having to go down into the underworld, have a fight with some bad monsters down in the underworld, and then is resurrected in a new form to live another day, right? This is the basic broad strokes of the story that the Sumerians were telling about what was happening in the sky. This was actually a deity that was traveling down into the underworld. Now, why do they think that it was what's the underworld to these people?
Death.
Yeah, why? Why do you think they thought of death as down below, as this thing going down and dealing with dead things? Yeah,
At the time they buried it.
yeah, they certainly did. Yeah, I think in some sense it is like that, right? People probably were quite aware for millions of years, or as long as we've been humans, and probably before that, that when you die, you sort of turn back into the earth in some sense. You go underground in some sense, right?
Yeah, they do bury. They bury their dead, and then when it became Rome, and when Rome stopped burying their dead, they started cremating them.
So that's
Came back, and then they put.
So that's like one layer of the metaphor, right? And yeah, you're right. There's people dispose of bodies in all sorts of different ways, but there is this sense that it's sort of recycled into the earth, right? The body at least, and they believe the soul went with it. And so they thought these planets were going down into that underworld where all this was happening as well. They didn't think of them as planets. They thought of them as beings, obviously. But there's something else to it. What's up with this resurrection thing? Like, why is the goddess rising up after having this whole ordeal down in the underworld?
Just comes back with the sun.
But why? What is that? What is that? Okay, let's take it as just an empirical fact. It rises with the sun. That we can work with that for a little bit. I'm trying to like dig up why they were actually associating this. Why this story was so critical. Let me just prove the point very quickly that it was important to everybody. So one of the next civilizations that crops up is super dominant in the Western story is the Canaanites, right? And these are basically the people that gave rise to the Hebrews, that gave rise to the biblical tradition. And they tell a similar story, actually, except the Canaanites, it has to do with a vacated seat of power by this supreme god, and another god who tries to sort of take the throne, but it doesn't work out, and he gets cast away down into the underworld. And there's no resurrection story, actually, with this one, which is quite interesting, because you don't see much of a resurrection story in the Hebrew tradition that follows from it as well. But eventually, the Christians come along, and they reinterpret this story from the Hebrew Bible to actually be a story about the descent. Yeah.
Well, I can point out what, because I'm Jewish, I can point out sort of, at least from my knowledge, why they probably didn't talk about a resurrection is simply because there isn't any real afterlife as a concept that much in
Interesting.
Judaism.
Interesting.
It's most of it is taken from the old, closer to the old Babylonian, Mesopotamian belief of just you join the earth once more, and that's it.
Interesting.
Um,
That's really fascinating.
yeah,
Yeah, I do think that it changes there.
it's,
But like the story that we only have 5 minutes left, and I do want to impress this point upon you, which is quite interesting. So in the actual Hebrew Bible, which is the next real historic piece that we have, I sort of skipped over the Egyptians. They have a similar resurrection story associated with Osiris that very much mirrors this. But the Hebrew Bible talks about, in some sense, there's a book called Isaiah, which tells the story. It's basically this prophet who's railing against the Babylonian kings that have them in captivity at that point in history. And he basically condemns this guy as if he is that deity that associated with Venus. He calls him the morning star and how he's fallen down into the underworld, essentially, right? And this is crazy because, still all the way into the Renaissance, like much, much later, the Christians are now talking about the morning star associated with this idea of Lucifer, right? They interpret this same story as this descent into the underworld. The angels rise up against God, but, they fail to overthrow God and they end up in the underworld. This is all associated with the story of Venus, this descent into the underworld. And in some cases, a resurrection again. Yeah.
And part of that, like Lucifer thing, is also because of the influence of the Greeks.
Tell me about
The
that.
Hebrew stuff, which led to the Christians, because I assume most people know about the story of the man who flew too close to the sun.
That's another one too. Yeah, that one actually appears too. The story of like the phoenix who's getting melted, right?
Those sort of ideas, a lot of Greek stories were of tragedy, in their sense, and a lot of coming and like people coming back from the dead. A lot of Christian or early Christian stuff was sort of like this mix, just a result of them being close to Greece. This mix.
There was a lot of syncretism, yeah, like stirring. So I'm not going to actually have time to interpret this for you guys, so I'm going to leave you to think about it. But I will tell you this before I let you go. The Mayans were obsessed with Venus too. They told a descent and resurrection story as well, based around their god Kukulkan. They clearly weren't well, we could fight about that, but most people would not think that the Mayans were in any way in contact with these people in the Levant or in Mesopotamia. The Egyptians have a similar story. Even the Aboriginals in Australia tell a similar resurrection story with this.
Didn't the Chinese also tell us?
I don't know much about the Chinese. I wish I did. I made an apology for that the first day of class. I really, it's very hard to access those histories and mythologies for me. So I want you guys to think, and we'll talk about this at the beginning of class next time, about what in the world it is about humans that want to tell this story about this star in the sky. Everybody's telling a really similar story. They don't even know about each other. Why is this story so central to what it means to be a human being?
So
Just meditate on it. I'm not going to keep you guys here, but let's talk about it at the beginning of next class.